All right, so let's consider preparation of alkenes. Please take down, please. The methods for the preparation of alkenes includes number one, hydrogenation of alkynes. Hydrogenation of alkynes. We've said when we say hydrogenation, it means I'm doing what there? Adding hydrogen. Take that, please. The hydrogenation of an alkyne, results in the production of a corresponding alkene. The hydrogenation of alkyne results in the formation of a corresponding alkene. Of an alkyne results in the production of a corresponding alkene. By corresponding, I mean the same number of carbons. Corresponding. Example, so here's the equation of the reaction. Of course, this one represents an alkyne. So alkyne plus hydrogen gives you alkene. So example, let's take N to be 2. If I take N to be 2, becomes C2. So C2, H into 2 times 2, 4, minus 2, 2. So C2H2 plus H2 gives you, we said N is 2. It becomes C2H into 2 times 2 is 4. What you have here is ethyne. So an alkyne plus hydrogen gives you an alkyne, ethyne plus hydrogen gives an alkene. That's 18. So I have this. Sorry? No. So I have this. Let's try to draw the structure. For this one here, C2, so I'm having C1, 2 is an alkyne. For an alkyne, I expect what there? A triple bond. So it becomes 1, 2, 3. This one to H, 1, 2, 3, 4, balance, 1, 2, 3, this one to H. So I'm having C2, H2, that's this, plus H2, so plus H2 to give you C2H4. C2, 1, 2, being an alkene means it has a double bond. Balance up. This one has 1, 2, 3, and 4. 1, 2, 3, and 4. So this becomes the structural formula. Ethyne combines with hydrogen to give you ethene. So that's the first preparation of alkyne. Alright, number 2 method of preparing alkenes. Now listen and listen carefully. If they ask you for preparation, bear this in mind. If I want to prepare alkene, I will have to do hydrogenation of what there? Alkene. If I want to prepare alkene, I'll do what there? Of what? Alkyne. Yeah, that is simple. If I see, alkane is double bond, alkene is alkane is single bond, alkene is double bond, alkyne is triple bond there. The idea is this: if I hydrogenate a double bond, it will break up this bond to give you an alkane. That's the concept. Also, if I hydrogenate an alkyne, 1, 2, 3, it will break off one bond to give you what there? An alkene. So please don't forget this, please. Number 2 method of preparing alkenes, number 2, is by dehydrohalogenation. Dehydrohalogenation of alkyl halides. Take down, please. The general formula for this reaction is given below. Quite a lengthy one. The general formula for this reaction is given below. All right, it's given as this. So you have this, where R is an alkyl group, an alkyl group member. X is what there? A halogen. All right, so I have this. X is a halogen, and I have that one as an alkyl member. We have this. Are we done, please? Take down, please. EASE, E-A-S-E, easy, ease. The ease of the hydrohalogenation of alkyl halide. The ease of the hydrohalogenation of alkyl halide is given by this one is called a tertiary alcohol, secondary alcohol, primary alcohol. We'll discuss what they mean in our next class when we treat alcohol. But keep it pending, please. Now, what this means is this, that it is easier for a tertiary alcohol to dehydrohalogenate an alkyl halide than a secondary, than a primary. So the most, so which one do I do there? The alcohol that has the greater potential or power to dehydrohalogenate an alkyl halide is a tertiary. The one with the least power is what there? A primary. That's the idea. All right, take down, please. Example under this, please. Example under this, please. Let's take R. I'm taking R now as butyl. I'm taking X as chlorine. R as butyl, X as chlorine, please. On your own, please, try to sketch out the formula. See what you get, please. On your own, please, try to sketch out the formula and see what you get, please. Take R as butyl, take X as chlorine. Get out the correct structure and name each of the compounds there. And name each of the compounds there. Give me 2 minutes. 2 minutes. Take this as a butyl. Take this as chlorine. Draw the complete structure. When you're done, name each of them, like each of the terms there. Alright, so look up, please. Look up, please. So for this one first, I'm having this as CH3 from here. 1, 2, 3 into CH2. C1, 2 into CH2. C1, 2 into CH. C, we said X will be attached to this. So Cl H, H. Is that okay? Yeah, so I'm having CH3, CH2, CH2, CH. Now it was CH first for butyl, that's CH2, and we said X, that's your chlorine. I have this, plus KOH, so KOH, passing through alcohol, alcohol, to give you this one here. Now hold on, look at please, hold on. What we should expect here would be, look at please, although this is an alkyne, don't forget we are trying to do what there, prepare what, an alkene. So to be the alkene of this, that means something of this nature. C 2, I have 4 here, 1 2 3 4, so 1 2 3 4, please add a double bond, that's this, please, because I'm trying to prepare an alkene. So if I combine, I'm having 1 2 3, 1 2 3, combines with this 1 2, this one I'm having 1 2 3, one more, and then 1 2 3 and 4. So I have this one here, this plus K, that's X, okay there, and then X is what there, Cl plus what there, H2O. So I should have something of this nature. So if you check this, look up please. If you check this, everything here is balanced. 1 2 3 4, 4 carbon. I'm having 1 2 3 4, 4 carbon. Look at hydrogen. I'm having in total here. I'm having 1 2 3 4 5 6 7 8 9. This one here 10. Here I'm having product side. I'm having 1 2 3 4 5 6 7. Where? 1 2 3 4 5 6 7 8 9 10. So hydrogen is also balanced. Look at potassium, K balance, chlorine, Cl balance, oxygen O1, O, they're balanced. So it's correct. So please just take note that it will be what there? A double bond there. So I'm having this. How do you name this? What do you call this? One or what? Or what? So listen please, what do you call this one here? Now listen, I discussed this stuff in the last class. I said this stuff here can be pronounced as either what there, an alkyl halide, or what there, haloalkane. As an look up please, as an alkyl halide, it means call the alkyl group before the halogen. In this case here, the alkyl group was what there, butyl. So as an alkyl halide, this one is called butyl, and then the halide, chloride. So I have this. Or call it a haloalkane. When I said for haloalkane, I'm calling the halogen first before the alkane. If I call the halogen first, halo, chloro, that's it. It becomes chloro, what's there? Butane. That's the name. Or better still, 1 chlorobutane. By adding 1 chlorobutane, I am showing that the chlorine is attached to what there? Carbon 1. So 1 chlorobutane. That's the name. What do you have here? Potassium hydroxide. What do you have here? Don't tell me butane. What do you have here? 1 butane. Or what's there? But 1A. What do you have here? This one here. So please just be observant. That's all. Be observant. That's all. Third method of preparing alkenes is dehydration of alcohol. All right. The dehydration of alcohols using acids result in the production of an alkene and water. Result in the production of an alkene and water result in the production of an alkene and water. Equation of reaction is given below. So you have this. Equation of reaction is given below. You have this. You have this. So an alcohol, acid, an alkene, and water. So you have this, please. Your first task, please. Please complete the structure, put H when necessary, and name each of the compounds there, please. For this, put H when necessary and name the compound, please. What do you have? Put H for each of these and name the compound. What do you have? That should be all there. Ethanol, please. OH is the alkanol. So having two carbon is et, that's ethanol. So ethanol undergoes dehydration using acid to give you what there? It's in and what there? Water. Let me use the prop. If I use prop is 3 carbons. I'm having 1, 2, 3. This one is prop. For it to be a propanol, there has to be an OH. So I'll attach OH here, and then perhaps complete the structure. I'm having 1, 2, 3, and then 4. 1, 2, 3, and then 4. 1, 2, 3, 4. This one here is what there? Okay, so acids, or use an acid there to give you a prop, to give you a propene. So I'm having 1, 2, 3. Put my double bond, of course, for the alkene. Put single bond. Complete the structure. I'm having 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balanced. Plus H2O. So this is an example. What I have here is propan 1 oil. Alright? Now, we'll talk about this one too. I've not taught you alcohol. I'll check alcohol here, please. This one here is not just a propanol. In the propanol or in the alkanol, you have to indicate the position of the OH group. For this one here, if I count from left to right, I have 1, 2, 3. If I count from right to left, I have 1, 2, 3. So if I count from right to left there, it means that the OH is attached to carbon 1. So hence, propan 1 oil or 1 propanol. That's the idea. So what do you have here? Prop 1 in. Or what's there? 1 propene plus water. So I have this. Listen. It is useless to say 1 ethene. Why? There can be no 2 ethene. Ethene is this. Look up. For ethene is double carbon 1, 2. Like this. If I count from left to right, it's 1 before this. If I count from that's from right to left. If I count from left to right, it's still 1 before this. So whichever way, it will always be what there? 1 ethene. So even if you say just ethene, it's still okay. I think same thing with propene itself. Same with propene. There is no 2 propene. Can there be 2 propene? Look at this, look at this, look at this. 1, 2, 3. This one gives you a prop. Let us say we want to put double bond here. That becomes 1 before this one here. So it's prop 1 in or 1 propene. What if I choose to move it here? Will it become 2? No. It will still be 1. Why? Because I will now have to what there? Count from this side this way. So I say about there 1. In other words, there is no prop 2 in. So if you want to say just prop in, it's okay. Because prop 2 in does not exist. So you can leave out the 1 and just say propene. It's correct. There is no 2 propene. Yes. No. At this level, no. Number 4, please. Number 4, please. Dehalogenation of vicinal dihalides. Dehalogenation of vicinal dihalides. Equation of the reaction is given below. Equation of the reaction is given below. Is given below. So you have this. Please do me a favor, please. Take X as equal to bromine. Okay. Put H, complete the structure and name each of the compounds. Take X as being bromine. Put H, complete the structure and name the compound. Please, what do you have? Now listen. If I choose to make each of these points H, I'll be having H here, H here, H here, Br here, Br. This compound what there? 1,2 dibromo what there? Ethane. 1,2 dibromo ethane. What we here? 18. Let's use a boot. So if I'm using boot is 4 carbon. So from here I'm having 1, 2, 3, perhaps. Okay, make it smaller, please. Let me use boot there. 4 carbon. 1, 2, 3, 4. Put the X here. I'll be having X. Sorry, we said X should be bromine. Br. Try to complete this one here. This man here is 1, 2, 3, 1 more makes it 4. 1, 2, 3, 1 more makes it 4. 1, 2, 3, 4. 1, 2, 3, 4. I have this compound. Moving on, plus I have Zn into this. Don't forget, I'm expecting a corresponding answer. By corresponding, I mean if I have 1, 2, 3, 4 carbon here, I must also have not less than 4 carbon and also not more than 4 carbon. So a 4 carbon structure here will give you another 4 carbon structure here. So it becomes something of this nature there. 1, 2, 3, and 4. So I have this. The problem now is now this. We said in our answer here, there should be a double bond. So where exactly do I place the double bond? Listen. The double bond will place in between the 2 carbon bearing the bromine. Listen and listen carefully. In this case, it is this 2 carbon that is bearing the bromine. In my final answer, these 2 carbon must bear the double bond. So hence, double bond will be here. So it means that if this one here was hydrogen and this one here was bromine, in my end result, these 2 are the ones bearing it. So these 2 must not have what there? A double bond. So please be observant. All right. Sorry? You see what there? Like this? They will not be separated. That's a distorted compound. It's not possible logically. So it will work. So let's say you're saying what if the was here and then the other was here. How do you draw a double bond? Like how now? So the idea will not be that does it exist? Perhaps at your level, don't worry. They will give you the one that's above this one here. So in your stuff, BR here, H. So these 2 bearing this will now have this. Complete this from having this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Yep, 4. 1, 2, 3, 4 plus Zn. plus, we said ZnBr2. So Zn, X is bromine, so Br2. In other words, please, which compound is this? 2,3-dibromo 1, 2, 3, 4 butane. Okay, this is zinc, of course. What do we have here? 2 butane or butane. And what do we have here? Zinc bromide. So that's how we do this one, please. All right, so let's move on to the next one, please. Number 5, please. The fifth one there is reduction of alkynes. Reduction of alkynes. RC triple bond CR combines H2/Pb or this Na or this. Your product is this R H. For this one, your product is this R H and H. So I have this. What you have here is a cis. This is of course, this is a cis compound. You know why it's cis, Abby? Yep. What do you have here? Trans. So you have this. Please. So this is the reduction of alkynes. So here's what it means. Please. There are listen. Here's what it means, please. There are 2 possible methods of reducing alkynes. Your result is as a product of your reactant. If I'm reducing alkyne using hydrogen or lead or nickel boron, if this one here is what you're using to react with the alkyne, I will have a cis structure of the alkene. Alternatively, the same alkyne, if I use sodium or lithium and what there, ammonia, you have what there, the trans concept. That's the idea. Let's take an example and see how it works. So let's say I have it like this. CH3 to C, triple bonded to C, C2H5. Combine this with, let's say, nickel boron. Please check. What do you think will be your answer? At the same time, write it down. Write it down. At the same time, let's say I have C2H5 combined with C, triple bonded C. I now had C3H7 combined with lithium or ammonia. Please, for each of these 2, please compare this now. Try to get out the products and name them, please. You don't have the luxury of time in the exam, right? So you have to be very smart about this. Here's the thing. This is an alkyne. Watch your reactant. We said when you react with this one here, what do you form there? You form a cis. So my first task is this. Generally carry this one here. So I'm having C1 combined to C2. We said H and H. So here becomes H, here becomes H. Observe something. Now listen, perhaps we could call this R1 and R2, call this R1 and R2, call this R1 and R2. The idea is this. We said R is an alkyl group. My first alkyl group we said will come here. That's all. In this case here, aside the C here, what is attached to the C is your R1. In other words, this one becomes R1. What do you have here? Methyl. What is attached to this C here is R2. This one here. So what do you have here now? Ethyl. Methyl, ethyl. Simply highlight this and bring it here. So I'm having this R1, there is CH3. So CH3. That's all. R2 here is C2H5. Just come here. We said put R2 here. C2H5. So it becomes C2H5. Draw the complete structure. This is correct. Of course, here is a cis compound. We explained cis and trans in a previous class. So it's a cis compound. Cis what? That's the question. First things first, how many carbon in total? 1, 2, 3, 4, 5. 5 is what there? 10. Please, how do I number? From left this way or from right? I'm going from left because this is 1, 2 as compared to 1, 2, 3. So I'm going this way 1, 2. So it becomes cis what there? Pent 2A or cis 2-pentene. As easy as that. Come here too, same concept. Pick up this one here. Okay, so if I look at this now, I'll just focus on what's the reactant. The reactant now is now lithium and ammonia. And we said if I combine with lithium and ammonia, I'll form the same geometric isomer, but a trans one. In other words, come here, put C double bond to C. Of course, H here. So come here, I'll put H. Come here, I'll put H. Now identify R1 and R2. In this case, obviously this one becomes R1. What is attached to carbon? In this case, obviously, here becomes what there? R2. So as simple as just replace them. That's all. So this one here becomes R1. So I'm having here as this one here, C2H5. Carry R2, bring it here. It becomes C3H7. So how do you name this compound here? First things first. In totality, how many carbon there? 1, 2, 2 carbon here. 3, 4, 4 plus 3 here. How many there? 7. 7 is what there? A hex. If I'm having a hex, how do I number this? Is it from left to right this way or from right to left this way here? It's from left to right. So 1, 2, 3. So because what there? Trans hex 3A. This should not take you up to 3 minutes. That's your answer. Just carry paste. That's all. No big deal. Yes, question please.
Alright guys, don't forget that you can get the complete organic chemistry course on my website. Simply visit www.jonahemmanuel.com/courses and then you see the organic chemistry full course. Alright, it gives you access to my detailed lecture on all the homologous series from alkanes, alkenes, alkynes, alcohols, ether, esters, including their nomenclature, their preparation, and all the reactions they undergo. Alright, or you can simply join my organic chemistry channel membership to get access to these video lessons. Alright.